Good morning, guys. Today we're going to go over examples 1 and 2 of 1.2. Now note, example 2 is a trickier one and it's also the more important one. But you'll see, we'll get to that. First of all, example 1, it just says estimate function values. Keyword, estimate. You got to give more or less a rough ballpark. Now when they present a graph, they might tell you to evaluate, for example, at what x value was my y3. So you just go up to y3, which would be this one right here, 1, 2, 3, and then see what x value was there. 1, 2, 3, 3.5 more or less. Or also you could be told what was y when x was 5. 1, 2, 3, 4, 5, and I go all the way up to my y value more or less here. And the answer would be, again, estimate 1, 2, 3, 4, 5.6. If you say 5.5, it's okay. If you say 5.4, acceptable. If you say 5 or 6, you would be wrong. So again, it has to be a somewhat rough, correct estimate. Okay, so just make sure you can use a ruler. I mean, if you need to use a ruler, you can just put a ruler to see exactly more or less where it falls and then just guess. 1 decimal point is enough because again, it's an estimate. It's impossible to say it's 3.55. Just don't, 1 decimal. Don't worry about it. Just make sure you're more or less correct. Now, these could be presented as word problems. Like, when was a company's stock worth $3,000? And then you go up to 3,000 and you'll say, okay, it was in the month of May. Or they can also ask you, for example, how much did the stock cost in, I don't know, February. You go to the month of February and you see how much it costs. So that's example 1, estimate function values. Pretty straightforward stuff. Now we're gonna go into the more important part and the trickier part, the concept, again, of domain and range. Now remember, let's just write it here. Domain, you only care about your x values. Domain, you only care about the x, where the function exists across the x. I'll give you a couple of examples. And range, we only care where our function exists along the y. Now let me give you 2 examples. And again, each one of these is 1 unit. Let's say, again, remembering the number line, I have this function. And let's say I have another function that is down here as well. These are 2 different functions. And I tell you, what are the domain of each of these functions? Even though one is on the positive y, one is on the negative y, they would both have the exact same domain because, again, I only care about my x. I don't care if my function is this or this. They would both have the exact, looks like a little ghost, Pac-Man ghost. They would both have the exact same domain because they begin at the same x value and end at the same x value. Again, same domain. Begins here, ends here. I don't care about my y values. I just care where it exists along my x. So what is an easy, or how do I just calculate this sometimes? You put your pencil on the left-hand side and you start scanning. Beep, beep, beep. You can make beeping sounds if that makes you comfortable. You start scanning, beep, 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 beep. Oh, I begin here. I begin existing here. So I exist, I exist, I exist, I exist, I stop existing. And there is nothing else on the right-hand side. So the domain is from this point where I begin existing, which would be -2, all the way up to this point, but not including that point because the little circle is empty. So the domain would be -2 greater than or equal to x less than 1, 2, 3. Again, I begin at -2 and I can include -2 and any x value between these 2 points up to 3, but not including 3, is part of my domain. Let's Now do a very small change. Let's change these little circles for arrows. What does this arrow mean? That I extend outward towards infinity. So no matter where on the left-hand side I place my marker, even though it's not shown on the graph, I know that this graph extends infinitely to the left and infinitely to the right. So in this case, the domain would be all real numbers or negative infinity less than x less than infinity. And again, the proper way we read this is, I'm sorry, I just go left to right, but the proper way is x is greater than negative infinity and less than infinity, positive, just in case. So that would be the case of all real numbers. Let's look at a different function, parent function that you know. This looks like a square root. And you know that square roots, we can't plug in negative values. So again, I don't beep, 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 beep. I don't exist, I don't exist, I don't exist, I don't exist. Boom, I begin existing, including that value. So I begin at 0, and I never stop existing on the right-hand side. So I end at infinity, but I never reach it. So x is greater than or equal to 0, and x is less than infinity. You can plug any x value into that equation, and you will get a real answer back. That's the domain. Again, along the x-axis. Also, you can have domains that jump, and we'll see that in piecewise functions. You could have a domain that has, for example, from here to here, and then from here to here, and then from here to here. Oh my God, that's crazy. Is that even a function? Profe. Yeah, I mean, if you do the vertical line test, it's a function. And we'll see that. Well, no, you should have seen that already. Piecewise function, this is sometimes what they look like. So what would the domain of this piecewise function be? Actually, let's just make it a little bit more complex. Let's just turn this into an arrow, see what happens. So again, I begin existing from negative infinity all the way up to here. Yes or no? Yes. But if you see, I stop existing infinitely close to this point because I can get as close to as possible to this point, but I actually exist up here. So there is no missing value between this and this, assuming they are directly on top of each other, because I'm getting infinitely close to this value, but once I reach that value, I exist up here. So the domain would be from negative infinity all the way to this value, which is 1, 2, 3, 4. So I begin negative infinity, negative 4, because again, I can't reach negative 4. And if you put your marker, at no point will it ever stop existing. Yeah, there's a jump here, but that doesn't mean it stopped existing. It exists up here. So if you scan, you would exist all the way up to here. But note, there is a jump here. From this value to this value, there is a jump. So for those values, you don't plug any values into your domain. So it doesn't exist. If you plug those values into the domain, you would not get an answer back, a real answer back. So it doesn't exist. And we continue. So we use the and, or you write and. For the moment, you can just write and if you're using set builder notation. And then we exist from this point to this point. 1, 2, 3, 4, 5, 6, and 6, x, 8. X is greater than or equal to 6. X is greater and less than or equal to 8. Again, I stop there. Since there is no answer, I don't reach positive infinity. So this would be the domain of this function. And again, you need to know how to write the domains in set builder and interval notation. If you are not clear, ask questions today, or you will be struggling this entire first half of the year. Understand the concept of domain. Make sure you ask questions. Now, the second part is the range, which is exactly the same, only we care about the y values. And again, you can beep, 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 and scan. It's exactly the same. These two functions, for example, this one and this one, they would have the exact same range, because again, I don't exist, I don't exist, I begin existing, and I don't exist. For domains, you don't care about the x values. You don't care how far to the right they are or how far to the left. If it exists, that is part of the range. So you answer the domain separately and the range separately. For example, let's answer this would be the domain for this particular function. Let's write the range. I begin beeping, I exist only at this point. Because again, it's a perfectly horizontal line, I exist there. So it'll be -1, -2, -3. So -4 is part of the range. So again, y equals -4, that's part of the range. And then I begin beeping, I exist at this value, and y equals 1, because I exist here. And I exist from this y value up to this y value, but not including that y value. So it also exists from 1 to, from 3, and y 3 through 6. I'm sorry if you can't, well, you can't see it. Let me write it down right here. So, and y, well, no, let's write it this way because it's not a constant. 3 less than or equal to y less than 6. That would be the range of this equation. The range would be -4 because I exist at -4. Again, I don't care how far to the right or how far to the left. I would exist at 1, so -4, 1, and I would exist from this value to this value. And that's pretty much it for range. It's exactly the same as domain, only applied to the y-axis instead of the x-axis. Ask questions if you have questions. This is incredibly important. Have a great day.